guys. So I have already tried to record this video once and now I'm trying to do it again. So hopefully it goes okay and you guys get all the information you need for your test tomorrow. I'm just gonna go over the review that we did in class and just go over some things that I saw that maybe you guys needed a little extra help on. So starting with asymptote, remember an asymptote is a line that approaches but never touches. Okay, so we know that a vertical asymptote is always going to start with an x equals, and a horizontal asymptote is always going to start with a y equals. Okay, so in order to find an x-intercept, you can analyze your graph for a zero or you can trace your graph. Okay, so remember you're going to graph it and then you're going to press menu 6-1. Then you're going to highlight where it's touching the x-axis and that'll give you your x-intercept. Okay, and for your y-intercept, you're going to graph it. You can trace your graph until it gives you a y-intercept, or you can make a table and look at x equals 0 on the table, and whatever y equals is going to be your y-intercept. Okay, now remember where your graph is undefined, you can find that from a table, or we can set the denominator equal to 0. So we got x plus 3 equals 0. You minus 3 to both sides, and you get x equals negative 3. So that's where your undefined. This is also your vertical asymptote. Okay, and then you can use your vertical asymptote to find your domain because it's all real numbers, but x cannot equal negative 3. Now for your range, you have to use your horizontal asymptote. Now when you're doing it from an equation, you want to plug in 500 and negative 500 into your table by going to the ask function. So remember, that's where you press your menu to 5 and set the independent variable to ask. And then you can plug in 500 and negative 500. And in this scenario, it's going to be approaching 2. So it'll look like 2.00 something and 1.99 something. So you know y equals 2. So your range is y does not equal 2. Okay, so that's the same thing for your second example. I'm just going to put the answers here. Let me see if I can, yeah, for your x-intercept, that is negative 2 over 9, comma 0, which I think is like negative 0.22. For your y-intercept on this scenario is 0, comma negative 1/3. Your graph is undefined when you have x equals 2. So your domain is x does not equal 2. And on this one, for your range, your horizontal asymptote, your y is going to approach 3. So your y does not equal 3. Okay. Now, going on to the next one, finding your horizontal and vertical asymptotes from a graph, which I feel like a lot of you are really good at. Remember, you want to go right in between where it's splitting off up and down and side to side. So right here and right here. And remember, your horizontal asymptote always starts with a y equals, and your vertical asymptote always starts with an x equals. So let's look at our graph. Y equals right here 1. So that's your horizontal asymptote. And x equals 2 right here. So x equals 2 is your vertical asymptote. Now remember, your range goes with your y. So your range would be y does not equal 1. And your domain goes with your x's, so x does not equal 2. Okay, so that's how you find your domain and range from a graph. We could do the same thing here. I'm just going to draw them for you guys. So we want to draw right in the middle of where it splits up and down, where it's approaching but not touching. And then our horizontal one, we want to draw right in the middle. Remember, your horizontal is going to be your y equals, and your vertical is going to be your x equals. Now, to find your vertical asymptote from an equation, That's when you set your denominator equal to 0. Or you can graph it, make a table, and on that table you want to find the x where y is undefined. Okay, and then for your horizontal asymptote, that's where you want to graph it, make a table by Control T. Then you want to set menu to 5, set your independent variable to ask, and then you want to make your table 500, negative 500, and see what your y is approaching. Okay, so on this question here, what is your vertical asymptote? That's x equals negative 3, because that's when the bottom, the denominator, x plus 3 equals 0, when you minus 3 to both sides. Now for your horizontal asymptote, if you make a table at 500 and negative 500, these are getting really close to y equals 2. So that's your horizontal asymptote. And then if we're looking at this one, your horizontal asymptote, your y equals, when you plug in 500 and negative 500 into your table, this is getting really close to 0.5, and this is getting really close to 0.5 from the other side. So y equals 1/2. And then for your vertical asymptote, that's when the bottom equals 0. So you have 2x minus 5 equals 0. You're going to plus 5. You get 2x equals 5, and then you're going to divide by 2. So x equals 5 over 2. Now for transformations, we've done this before. You might want to have your transformation on your note card, but when it's underneath, that moves it left or right, and when it's outside, it moves it up or down. So remember, your x is always lying to you. So if it's a plus 6, it's actually moving to the left 6, and if it's a plus 2, it's moving up 2. Okay, on this one, you're just looking for where your number is, and the number is after the equation. So after the equation, after your division sign is up 3. On this next one, we got a plus 7 underneath. Remember, your x's always lie, so we're actually going to the... Okay, so we have the minus 4 on the bottom, which tells us it moves left to right, and minus, we would think it moves to the left, so it moves to the right. And for our minus 2, that's after the division sign, so that's going to move it down 2. And then finally, this one was a little bit tricky because of this negative out front. Okay, most of you guys knew that this 2 meant a stretch by 2. But that negative out front is what got a couple of you guys, which is a reflection over x. Okay, and then the parent function for the rational is y equals 1 over x, or f of x equals 1 over x. So if you're trying to see like how it moved left, right, up, or down, you want to always start at 1 over x. So let's look at an example over here. So a reflection, this one has a reflection over x. So we know it needs to have a negative out front. Then it says it's going to move up 5. So it needs to have a plus 5. Okay. And then left 4, if you're not sure if it's a plus or a minus, though it is a plus, just graph it and make sure it moved to the left 4. So this one has all 3 of them. So that's going to be your answer for that transformation. Let's look at another example. It says stretch by 2. So a vertical stretch by 2. So that's going to be on the top. If it's on the bottom, it's a shrink. So these two are stretched by 2. Now, right 5, right typically is positive. So we want to look for minus 5s. Okay. And then down 2, we're looking for a -2 outside. And this bottom one right here is the only one that has all 3 of the transformations. Now, if I was going to write an equation given some transformations, so say it says it's a shrink by 1/2, it moves left by 3, and it moves up by 5. Okay, so I'm going to write, let's call it g of x equals 1 over 2x. That gives you your shrink. This 1/2 gives you a shrink. Okay, it moves left, so we know we're going to do opposite of minus, which is plus 3, and then it moves up 5, so that's a plus 5. So this one goes with your up 5, this one goes with your left 3. Now, if I wanted to write an equation from a graph, we're going to look at our horizontal and vertical asymptotes. Okay, so this one goes like that. We're going to draw a line right in the middle of where they split off. We're going to call this one moved right 1. This one moved down 1. And notice it's going in the opposite direction of what we usually have. So our typical parent function looks like this and like this. But because the red is opposite, that means it's a reflection. So we want to make sure that we note that it's a reflection. Okay, so to write our equation, let's call this one f of x. We want to put a negative out front for our reflection. Since it moved right 1, we're going to do -1. Since it moved down 1, we're going to do -1. Okay, and that's the equation. Now, let's look at another example. We're going to do our horizontal. We're going to look at our vertical asymptote. Okay, notice it goes in the same direction as our parent function, so we don't have a reflection. But this moved up 4 from 0, 0, and it moved left 3. So if we're going to write an equation, let's call this one h of x. We have 1 over x. To move left 3, we're going to do a plus 3. And then to do up 4, we're going to do a plus 4. Okay, and that's it. So that's all we did for our review. So remember, for your review, for your test tomorrow, you're going to do asymptotes. You're going to find asymptotes from equations. You're going to find them from graphs. You're going to find domain and range. Let's find the domain and range of this one just to be sure. So because we have an asymptote at y equals 4, our range is y does not equal 4. Because we have a vertical asymptote at x equals -3, we know our domain is x does not equal -3. Okay? So we find domain and range. We can find x-intercepts by analyzing graphs for zeros. We could find the y-intercepts by looking at the table at x equals 0 and seeing what the y value is. We're going to do lots of transformations, so just making sure you understand transformations. And another thing you might want to note is you cannot have an x-intercept when your horizontal asymptote is on the x-axis. You cannot have a y-intercept when your asymptote is on the y-axis. Now, why that is because we go back to the definition of an asymptote and we know our graph gets really, really close to those places, but they never actually touch those places. Okay, so good luck tomorrow. I hope this helps.